Let's work on problem P6. In this problem, we are to use exponential smoothing approach with damped trends. We've been given the data for October, and we have been given the actual value for November, and we have to forecast for at the end of the November to the December. So we have to forecast x 10, 11. We are forecasting for December from 10. Okay, so the formula really is, so tau equals to 1 because the difference of 10 and 11 is 1. There is a part and there is a b part, right? There is a b part and there is a damp variable here. So the way to break this down is, given our tau is only 1, so this really, this circle part that I have circled breaks down to this, right? I equals to 1 to I equals to 1. So phi 1 be 10, then we are done because I ends at 1. What if this was 2? What if the tau was 2? Basically, if you are sitting at November and forecasting for January, then I equals to 1 to square, right? So this would expand to phi 1, our first round, I equals to 1. So phi 1 b hat 10 plus, now I moves to 2, phi square b hat 10. If there was 3 plus all this thing, this summation means plus, right? So that would, this part would break down into, depending on how big is your tau, that many numbers of polynomials you would get. Okay, so basically how far ahead you are forecasting, that many numbers of polynomials would be there. Now if you think about this, why this is called damped. If you're forecasting from November to January, think about this phi square. Phi is a very small value, square of it is a really small value. So that would damp your forecast as we further go along. Think if it was phi cubed, that would be even smaller, right? But our problem is only tau equals to 1. We are in November and we are forecasting for December. All right, let's get started. All right, first value is AT. AT is really, in this case, 10, or this should have been 8. I should have written A10 and B10. So this is really, the hard problem is translating from this green to this brown one. AT really is 10. T is 10 in our case, okay? So this would have been A10 minus A9. And this would have been B9. T is 10, right? All right. So BT minus 1 is B9, okay? Equals to A10 is alpha times x10, that is the variable we just saw, plus 1 minus alpha times, let's put this into braces, AT minus 1 is, remember T is 10, so AT minus 1 is A9, that is the old value, plus phi is 0.9 times BT minus 1, our previous estimate of B, that's good, that's our new AT. Now we can calculate BT, or B10. B10 is beta is 0.1 times A10 minus A9, A10 minus A9 plus 1 minus beta, 1 minus beta times phi, our phi is 0.9 times BT minus 1, our previous estimate of beta, that gives us a new beta value. Okay, now we are ready to calculate x hat 10, 11, that is given by A10 plus, so this part really breaks down to phi to the power 1 times B10, phi to the power 10, phi to the power 1 times beta 10. Beta 10 is this. So this comes down to, let me make this little 36. Okay, so it comes down to 36. So that's how you calculate the the damped exponential smoothing method.